So this is a topic number 2, which I'm going to explain, data engineering fundamentals. Now that you know what a data engineering does, and let's move how things work. So here in this part, we will understand simple fundamentals like what are data pipelines, what is the difference between batch processing and stream processing, and what is ETL and ELT, and how to keep data clean. And let's start step by step here. What are data pipelines? A data pipeline is like a water pipe. It connects a source from where the data comes from and to a destination where the data is getting stored. In between, the data is filtered, cleaned, changed, and then saved. So here, the pipelines can be quite simple, like copying the data from Excel to a database, or it can be even complex, like real-time stock market data flowing into the dashboards then and there itself, real time. So without pipelines, it is impossible to move big data in a safely manner. For example, in a college, when you submit your assignments to administration office, they will check your name, your roll number, and they will arrange your class and send to the HOD. This is like a simple pipeline. And now let us try to understand what is a batch processing and what is a stream processing. A data can be processed in two different ways. Another one is a stream processing. What is a batch processing? Collecting the data first and then processing it later. I mean to say with a delay. So if you take an example, you can take a report of all the Amazon orders that were placed yesterday. In the same way, if you go with the stream processing, this kind of a processing of the data is almost like a live. How exactly the a cricket game which we are watching is live, okay, where it is getting relayed uh, from wherever it is through the satellite as it comes. In the same way, here the stream processing goes ahead with the live streaming of any data, showing the live cricket match scores for every ball that was hit. So the batch process is a little bit slow, but it is very simple to work on. And whereas the stream processing is fast, but it is complex to work on. But both are these two can be used with business needs. What is ETL and ELT? So here, ETL and ELT are two different ways of handling the data here. What do you mean by ETL? It means extract, transform, and load, where what exactly we are doing here, first we will clean the data and then store it, where you could correlate with an example like correcting the student names before saving it in the database. Whereas when it comes to the ELT, means extract, load, and transform, where here we will store the raw data first and then we will clean inside the database. If you take an example, we're uploading all the mark sheets first and then clean later. So ETL is used when we want to store only clean data, and whereas ELT is used when cloud storage is cheap and we want a flexibility. Here let comes to the data quality. We always look forward the good data. Okay, let's go ahead with the data quality dimensions. What do you mean by data quality dimensions? Here, we always look forward for a very clean and the good data. Why? Because this clean data is very, very important. If your data is wrong, then your reports, dashboards, and models will also go wrong. So, on what factors that we are going to qualify this particular good data? Number one, accuracy, whether the given data is correct or not. Number two, completeness, whether the given data is completely provided or not. Number three, timeliness, is the given data is the latest data or is it a previous data? Number four is uniqueness. Do we have any sort of duplicates inside the given data? Consistency, is the data matching in all the systems or is it in sync with all the databases. So we need to ensure that the data quality is always in place. So as a data engineer, our job is to make sure the data is clean and trusted. So coming to the data modeling basics. The data modeling is one of the important part that every data engineer must practice. Here, the data modeling means how we design the shape of the data. Like when we arrange items in a cupboard, shirts in one place, books in another place, and in the same way, we organize the data into the different models. So there are three levels here. One is a conceptual model, number two is a logical model, and number three is a physical model. Let me tell you, what do you mean by conceptual model? It's a very high level model only for the business perspective. I mean, where you can watch the conceptual model for the business view. As a sort of an example, students, exams, results for any sort of educational institutions, we can consider this example with no columns or details. Whereas coming to the logical model, it will contains fields and relationships as well. For example, student table, which has the roll number, student name, and the table will get linked to the exam table as well. So this is the logical model, literally. When it comes to the physical model, actual database tables along with the indexes and constraints can be considered as a physical model. So this physical model is more or less like a physical SQL table and the primary keys which are existing in within the database. So extending it furthermore to understand about this particular data model, let us take an example of two common structures which are called the star schema and snowflake schema. What do you mean by star schema here? Whenever there is a table which is generally considered as a fact table, one main table can be considered as a fact table that is connected to the multiple smaller tables which are called as a dimensional table. Okay, that is called a star schema. So when I'm talking about a fact table is nothing but the measures. I mean to say the numbers. Whereas coming to the dimension tables is nothing but the categorical data. So critically, this kind of a star schema is used for the reporting purposes. When it comes to the snowflake schema, this is like a star schema itself, but the dimension tables will be broken furthermore, where we will use this snowflake schema when you need a normalization and wanted to save some storage. So you will see this kind of a stuff in a lot of analytical projects. Okay, so now let's jump into the workflow orchestration. Whenever you build a data pipeline, you don't want it to run it manually every day. Then what you will do? You want it to run automatically at the right time in the right order. This is what we call it as an orchestration. So here, the orchestration means scheduling. I mean to say, like you are going to run the job at 6 a.m. every day and handling errors as well. I mean to say, like if something fails, you have to try again or send an alert to the respective stakeholders. And then dependencies, like run job 2 only after job 1 is successfully finished. So this kind of dependency running the job. So the last one is a monitoring. You need to monitor, keep on monitoring the job when it is getting executed in the background, whether it is going to yield a success result or a failure report. So think of it more or less like a bell system in your school, like it rings automatically for classes, lunch, and exams. You don't need to remind it every time. Likewise. So let's go to the orchestration tools. So what kind of orchestration tools that we can work with? In order to handle this, the orchestration, we have some tools which are very popular. Here I can just introduce you something called the, so likewise, you could see that even Prefect and Daxter, okay, all these things are different tools that we can use it for the orchestration purpose. So this will help us to automate, monitor, and retry the pipelines. If you're new, you can start with the Azure Data Factory, which is very easy, and later on you can explore even Apache Airflow, which is quite popular and being used in many projects. And coming down to the real world scenario, let us take an example. Let me give you one real example here. Imagine there is a streaming platform like Hotstar or Amazon Prime Video or Sony Live. Here is what a data engineer would build. Every day, the viewership logs, I mean to say what people watch. inside this Hotstar and all will be collected and saved in the Azure data lake, let me say. And live ad impressions, which are going to be captured using the Kafka and stored in the Cosmos DB. And then transformation happens using the Synapse pipelines to clean and prepare. And the reports are shown in Power BI dashboards. So this is a hybrid architecture, which is going to be like a batch and stream the data together. I mean, we are implementing the batch process and also the stream process both together. And here, this is how like we will see in many organizations, like the combination of architectures with the different tools involved in order to perform this certain stream process, in order to perform all the data cleaning, data gathering, data transformation, and then data storage in the data warehouse, and finally releasing that data for the reporting purposes. So this is end of this topic. Thank you.